What's up, everyone? Today we're going to talk about tree diagrams and probabilities, so let's get into it. So tree diagram is another way to represent all possible outcomes in an event, like we saw with sample spaces a couple periods ago. It can show information more efficiently by attaching a probability to each branch. And the end of each branch represents a combined event. So let's say we were to flip a coin. We have our branches. At the end of each branch, we'll say what it represents. So I can either get a head or a tail when I flip that coin. And along the branch is where your probability goes. So I have 0.5 or 1/2 chance of getting a head, and the same for getting a tail. So now let's say we were to take that and expand it to flipping 2 coins. We would keep that same first branch, and this would represent flip number 1. Flip number 2, we'll have to put it twice. We'll have to draw that same flip twice, or that same outcome twice, because one for getting if I got a head first, and one for getting if I got a tail first. If I were to, want to know maybe what's the probability of getting one of each, one heads and one tails, what I would do is I would look for the branches that I need. So I would need head and then tails. So I would need this branch, and then tails and then heads. So this branch, because again, I'm looking just for one of each, one heads, one's tails. In order to figure out those particular probabilities, what we do is we multiply the probabilities from the branches. So 0.5 times 0.5 gets me 0.25. And same deal with the tails and then heads. So 0.5 times 0.5 still gets me 0.25. But since we're looking for the probability of just getting one heads and one tails, not a particular order, once we get these probabilities, we add them together. So there's a 1/2 chance or a 0.5 chance that I would get one heads and one tails. So we multiply along the branches, and if you're using more than one branch, you add up the probabilities.